So there is a provision of concept of enums in C programming languages. So basically enum is also a type of functionality that is designed in order to increase the utility and increase the functionality for the user. So basically it is a special type that represents a group of constants. Okay, so just like union and structure, it has been declared in the same way with a different keyword. So its declaration is done using this enum keyword, and you can write the name, whatever name you want. And for the sake of just understanding, we are giving a simple attributes low, medium, and high. You need not define it. You need not give the data type or something right now. So you just need to declare it in a certain way. You can give it something or the other, I, j, or whatever you want. So this is how enums are declared, and the functionality of what is the use is we are going to see further. So the note here we need to say is ki the last item does not need a comma. So basically we are putting a comma after every attribute that we were not doing in union and structures concept, right? For this union, you can see we are declaring it and declaring the variables and putting the semicolon, but here we are going to do it using the commas, and for the last attribute we are not going to put any comma. This comma has to be omitted. This is not required, right? It is not required to use uppercase, but often considered as a good practice. Means कि here we are writing the variables in the uppercase, but it is not a mandatory thing. We can also define it in a way we want, but for the conventional use or a certain conventional properties, we write it in an uppercase, but you may write it the way you want. And enum is a short for enumeration, which means specifically listed. Means we are going to give a constant value to it. Means we are going to specify that this low is going to be the same. Like if we are putting a value 1, that is going to be same throughout the program. And this is not we were doing in structures. We were creating different variables and putting different values, but here we are specifically putting a certain value, and that is going to be the same or the constant for the entire program. So moving on further, so this is how the variable would be declared. And now you might see one thing, that the keyword is the same, the name of the enum is same, like here it was also level, and here we are defining it with level only. So just like the structure and union concept, we are doing it in a same way, putting the keyword, putting the name, and putting the variable name that we need to create. And now enum level myvar is equal to medium, so we are assigning it with a attribute that was given. So here we are putting it as medium. So what the use is, so basically if we are declaring it, okay, and we are putting my enum level myvar is equal to medium, and now we are trying to print myvar. Okay, so what it's going to do is ki if we are not putting any value inside it, by default it is going to take the value 0. Like first we defined low, no, first it was low that was defined, yeah, low, medium, and high. So for low it will take 0 automatically, for medium it's going to take 1, and for high it's going to take 2 automatically, because we have not defined, and by default it has the provision of taking the values. So what would the answer be? The answer would be 1 over it. Why 1? Because we are putting the value medium in myvar, and medium is having the value 1 as per the default convention. So this is how the functionality will work. If we need to change the values, so while declaring the enumeration or while declaring the enum, we might put 25, 50, or 75 in the value. So now if we will try to print low, like if we will write enum level, and let us suppose a is equal to low, and now we are trying to print a, then tell me what the value would be. The value that is going to be printed is 25. This time it's not going to be 0. Why? Because that was the default case when we are not defining the values, but here we are defining the values at the time of declaration only. Then it's going to take the value that is given by the user, so that is 25. That is as simple as that. And moving on further, so this works in the same way. Like if we have given a value 5 to this low, so automatically the value 6 would be given to medium, the value 7 would be given to high. So just the increment is going to be done, and the accordingly the values are to be given. So if we are putting 5 in low, so automatically the increment will happen, and medium will be getting the value of 6 and high would be getting the value of 7. So this is how it would certainly work in a certain way. And we might also use it that if we try to print low, it would print 5. If we try to print medium, it would print 6. And if we try to print high, then it would print 7. So this is how we need to understand. So we can also use a switch statement as the values are same. So we have put 1 in low. So if we see low, if we see medium, so I'm just writing shorthand of high for it. So in low it is 1, so automatically in medium it's going to be 2, and in high it's going to be 3. So in main we are creating a variable where we are putting a medium value in my var. So for my var, or I'm just writing my, we have the value of medium, that is 2. And now in switch we have written my var. If case 1, if my var is having the value 1, then it's going to print low level. If the my var is having the value 2, case 2, then it's going to print medium level, and for case 3 it's going to print high level. So accordingly the control will come to switch statement. Case 1 will be false because the my var value is 2. It's going to case 2 now, and for case 2 it will find that yeah, the condition matches, the my var value is 2. It's going to print medium level, and it's going to break the statement, and the execution will end. So certainly what the output would be, output for this program would certainly be medium level. And why, we have seen the execution, that how is it done. That is going to be medium level. So further, why and when to use enums. So basically enums are used to give names to the constants. So if we have to define a constant like 100 and we have to use it certainly again and again in our program, so we need not write 100 again and again and again, or we need to create a sequence of constant, just like we saw now ki it takes the value, if the low value is 1, then automatically it would increment and put the value of 2 in the next variable. So certainly we need to create that sequence, or we need to use constants again and again, then we can use the concept of enums. And after that we can use enums when we have values that we know that we are not going to change, like month, days, colors, because color values are not going to change. If that is red, that is going to be red only. Okay, so in that conditions we can use enum concepts. Apart from that, we have a bit field concept as well. So this is a bit field concept. So basically if we try to understand it using the concept of structures, then it would be quite easy for us to understand. So let me write, it is bit field. And okay, so if we are defining a simple structure, okay, so by default what the structure does is key structure automatically takes 8 byte of memory address in C programming language. Means it is automatically going to take 8 byte of memory by default. And it might be a possibility that we are not defining enough attributes or entities inside that structure, and it is taking a lot of memory. So in order to reduce that memory space, the usage of memory space, and enhance the code, then we can use the concept of bit field. And while assigning the variables, like if we are putting unsigned integer with validated and putting colon and writing 1 and writing here 1 as well, so this is a different structure. This is a structure 2 and this is structure 1. So for this structure 1, it is going to take 8 byte because we have not done anything, but for this we have defined semicolon 1. So what is going to do is key it is going to occupy a less memory space. It's going to occupy a less memory space for this because we have defined a certain amount of value to it, a certain amount of constraint that it's not going to take a certain amount of memory. It's not going to take 8 byte by default. It's in this case it's going to take 4 byte. So in main function we have done the same concept, that we have printed memory size occupied by status 1 and used the size of function of status 1, and that is going to be 8. And for this memory size occupied by status 2, we have put the size of status 2, and that is going to be 4 in this case. So the memory space is automatically getting reduced during using this bit field operation. So that is why the bit field operation is necessary for uh, optimizing the code or reducing the usage of memory space, because in simple declaration we were using 8 byte even though it was not necessary, and in bit field operations we put a certain constraint and now it is utilizing only 4 byte of memory. So that's how we can reduce it, the usage of memory space, or optimize our code.